Good afternoon, ladies and gentlemen. I'd like to take the opportunity to acknowledge the traditional owners of country throughout Australia and recognise their continuing connection to land, waters, and cultures. We pay our respects to elders past, present, and emerging. I'd like to thank everyone for attending today. Thank you for giving up your time, and also for AIPM for their kind invitation and asking me to speak on matters of defence projects and really focusing on the contributions that a change to fundamental inputs to capability has made. Certainly, in as I observe things anyway. Brief introduction. My name's Craig Shaw. I'm the director of Mirador Capability Solutions, a small specialist consultancy.
For myself, I spent 7 of the last 9 years in Navy infrastructure, delivering infrastructure projects, capability, and also sustainment projects in the estate, and 12 months doing the capability and technology management course, a 1-year master's program. Prior to my full-time Navy service, I had 13 years in the Australian Public Service, doing a number of jobs ranging from defence, doing some master planning, and a number of other positions in a number of different agencies. Funnily enough, a lot of it was project-based. So that's a little bit about me. What I bring today is really my perspective, observations, conclusions, and even some recommendations that as project managers, I would suggest we take forward in our profession in delivering defence projects, but not just for defence. I think the applicability goes beyond that. But let's hook in. I'll quickly like to go through the content. The first couple of points that I'll be presenting today is really around context, being the success tetrahedron and the fundamental inputs to capability. Then I'll spend some time talking about some implications of those to project management and systems engineering and the coordination or difference between the two. Planning horizons. The capability should be viewed as an outcome and not an output, and the importance that makes in how we do the work that we do. And then finally, 7, because apparently we've all got to have odd numbers to suggestions of driving success in defence or projects in general. The 4 key takeaways from today that I'd like to leave you with as written. I'll give you a moment to read those for yourselves rather than my dulcet tones to carry off on those. All right, success tetrahedron. This will be familiar to should be familiar to all of you as project managers. The iron triangle, where cost, schedule, and scope is balanced, and somewhere in there that we achieve the elusive project success. Certainly, as the thinking developed around projects developed through the 50s, 60s, 70s, that was 80s and 90s. Well, now I'm feeling old. That was the focus. However, certainly in defence, the issues started to become evident in that projects were being developed, equipment, platforms provided to defence that weren't hitting the mark. And in 2014, the Australian government initiated the first principles review, which resulted in the formation of the Capability and Sustainment Group, CASG, and soon thereafter led to the capability life cycle and maturing of that into the One Defence capability system. The reason that came about is that, as I said, that the outputs of projects weren't hitting the mark. We weren't really hitting satisfaction for our clients. We were providing platforms that couldn't be sustained or weren't adding capability or sufficient capability to defence. That resulted in, well, one of the large outcomes of, or key outcomes of the CLC and One Defence capability system is a focus on what are now the 10 fundamental inputs to capability. Well, I'll talk to those a little more a little bit later, but needless to say that the focus started to shift towards client satisfaction, which became really the fourth vertex of the tetrahedron. So now success became a lot more focused on not just cost, scope, and schedule, but also that client satisfaction. Now, that client satisfaction is a rather, and as you'd all realise, is a rather convoluted beast, but we've had many parts, and it's around the consideration of client satisfaction that a lot of today's talk will focus. Now, we've all got to have a clear definition of what we're talking about. So, and my apologies for the many words, but capability. I think it's important that we establish what a capability is, and that's the power to achieve a desired operational effect in a nominated environment within a specified time and to sustain that effect for a designated period. That capability is generated through combining FIC. I won't go on, but I'll give you a moment just to cover off on the rest of that definition, because I think that it is important in terms of what we're about to launch into. So the One Defence capability system and fundamental inputs to capability were really in response to what was historically a system that was focused on major systems, aircraft, vehicles, and ships. The big shiny toys. They dominated consideration of defence procurement and acquisition projects. With the advent of CLC and One Defence capability system, the focus changed towards the capability, not by demoting major systems, but by elevating the other FIC around it. It's true that a ship is a very expensive steel bucket without a crew to sail it, without ammunition from which to launch from it, without the engineers and industry to sustain it, and without collective training systems and command and control systems to actually ensure that system delivers the effect. That was a key change that I've seen in defence acquisition, that those other integrated logistics systems have come to the fore, and there's been a significant shift in how we deal with those in defence procurement. Of course, FIC is just a construct. Here in Australia, we have now 10, it was 9. And as of March this year, data was introduced into the, for want of a better term, stable. In the UK, they have the integrated logistics support, which has 13 elements. In the US, they have integrated product support, which is 12 elements. Now, as with most organizational structures, they are structured. They are constructs and are somewhat arbitrary. But nevertheless, they do give us a structure and something to work to. As I mentioned, the CLC and One Defence Capability System changed the focus from specific to major systems to capability. That created also changed an output being the major platform to an outcome. We're now looking to ensure that we can create an effect in the battle space with all the incumbent requirements behind that, the people, the training, etc. However, platform-centric thinking still dominates. It's the nature of the beast. It is certainly in terms of uniformed personnel, we tend to think about those platforms. We strongly identify them, and indeed a lot of activities are based around them. So it's a very natural human thing to be drawn to the two major systems. However, rebalancing of the FIC continues, and to a degree that'll be one of the focuses of the rest of today's talk. I would like to take a moment to take a little more expansive view, however. One of the things about capability is that capability can be delivered by several major systems. Surface combatants, for example, contain both Anzac-class frigates and Hobart-class destroyers, just as an example. So the major systems within a capability are actually transitory. They're acquired, they're sustained, and then they're disposed of. However, the other FIC, personnel, industry, support, engineering, facilities, persist over multiple major systems and indeed serve multiple capabilities. So one of the key parts of defence procurement and project design and development is that the recognition of integration into extant systems has been improving, but I would argue continues to need to be improved. It also means that there's implications for planning horizons, and I'll touch on those in a moment. What it does, with that background, there's a heightened importance for stakeholders in determining success. It's no longer just the owner of the platform that will determine success, but also our ability to train, to sustain, for industry support, to supply that capability with all the requirements. And each of those come with their own suite of stakeholders. The other thing is that those stakeholders generally have action through time. So whereas before the traditional time period for most project managers, or that most project managers were interested in, ended at project closeout. After that, had no control, no interest, which is perhaps a little bit harsh, but certainly there was some attributes, or have been some attributes of that in the past. However, as an outcome, now major systems need to be used to deliver the outcome. Therefore, that time period, the horizon that needs to be considered within a project, needs to extend beyond project closeout and actually go all the way through to disposal. It also increases the number of horizons. Not current view, past view is still valid, but it's opened up the need to look to future horizons. Collaboration is critical to bring all those disparate stakeholders together. And because of the length of the programs, particularly with large infrastructure, capital equipment, common in defence, knowledge, assumptions, and expectations management is key. Knowledge management, so that what is considered, what is determined early in the project is not lost and actually can be communicated to the eventual users that may be a decade or so in the future. Assumptions, we've all run afoul of assumptions if we've delivered any projects whatsoever. It is very true to assume is to make an ass out of you or me. And expectations, because of the length of projects, expectation management needs to be a new consideration, or at least an extended consideration for project managers, I would argue. I'd just like to now so that's a context. Now just stepping into project management and systems engineering. Firstly, they are not in competition with each other, but I see systems engineering as a tool of a good project manager. They have some different attributes, which I'll touch on here. So primary focus for project management, delivering projects according to scope, schedule, and budget. And now I would hold that it's also client satisfaction. Systems engineering, delivering functioning systems that meet the needs. Now, meeting the needs is definitely a client satisfaction activity. Core activities, planning, budgeting, execution versus requirements, design, integration. Lifecycle orientation, in the past, very much the project lifecycle, whereas systems engineering, that system lifecycle. Certainly in terms of my limited education in systems engineering, it's from concept to disposal. Tools and frameworks, and the primary drivers being project deliverables and versus system capabilities. Nothing new there. But considering the move or the emphasis that we're now placing on client satisfaction, the length of projects and the consideration that project managers are expected to hold, or at least that I would argue need to hold, some of the attributes of system engineering need to be rolled forward, or at least become more of a project manager's vernacular. But they are still quite different. I would argue that project managers' view need to be more up and out in terms of their integration and coordination of stakeholders. Systems engineering, while still having a view of external needs, certainly around designing the system and the system of systems. What that can extend into is some of the the considerations that a project manager may need to take on board. Now, my apologies for any and all system engineers that might be online today. These are a particularly poor example of context diagrams and operational viewpoints. The practitioner is myself, and is not the best practitioner of the art form, as you can see. But what they do hopefully show is the complexity. And I should say these are mine were done for a court and therefore fictitious. Hopefully illustrative though. So context diagrams showing the complexity that is incumbent in all defence capabilities, particularly when we start looking at 10-FIC. And I would implore or recommend that project managers use their system engineers to assist them to produce a series of operational viewpoints, one for each perspective of a FIC. How systems will be supplied, how engineering support will be provided, etc. And each of those will give a slightly different and important alternative view. Just to speak a little bit more on the planning horizons. Historically, those planning horizons equated with responsibility. Project manager responsible to the end of the project, therefore the horizon that they worried about pretty much ended at that point too. In my past, I certainly have had project managers state, what do I care? Project's done and dusted by then. What you do with the kit is up to you. I'd like to think that we're a little more enlightened than that now. And indeed, that project managers are taking a much more extended view. On the bottom, the graphic there is taken from Michael Ryan from his publications on systems engineering, and shows 4 phases of capability lifecycle, being pre-acquisition, acquisition, utilization, and retirement. Doesn't matter what you call them as such, and the 4 different disciplines that occur through time or dominate through time. The important point here is on the right-hand side, it's showing that each of these disciplines extends to retirement. And so while your responsibility may not extend that far, certainly your consideration of the project and the project deliverables or the system that you're delivering needs to consider that. And that's certainly as we move from a major system to the capability mindset. Just to take a little bit of time of what that means in actual years. I've taken the liberty of looking at a fairly typical defence acquisition of major capital equipment, and looking at the kind of timeframes that we talk about. The integrated investment program, and being the future planning for major acquisitions in defence, is a 10-year investment program. Pre-acquisition phase for a project can be 2 to 5 years, depending on its complexity and size. Acquisition can be 2 to 15 years, depending on the size and the complexity of the system in question. And if we're talking about ships, if you're delivering on a class of ship over with a 2-year drumbeat, can easily go out to 10, 12, 15 years or more. And certainly that's what we're talking about in terms of nuclear powered submarines. In-service phase, 15 to 25 years, depending on the system. And then the retirement phase 5 to 10 years, depending again on that drumbeat of systems paying off. The somewhat scary thing is that those capabilities around a particular major system can total somewhere between 34 and 65 years for again, a large capital equipment purchase. That is in contrast to defence strategic planning of 20 years or extending even to 30 years. In the main, however, with 20 years, the second half of the design life of a piece of equipment is not necessarily being given any consideration. That in itself represents a fairly significant risk to a project, but also an opportunity. So very quickly, let's launch into some of the challenges that all produces. Firstly, the mismatch in planning horizons. The capability planning horizon, as I said, is 34 to 60 odd years, whereas the strategic planning to support that may have only been 20 years, leaving half of the lifespan unaccounted for. Concept maturity. It wouldn't be the first time, and certainly those that may have had the pleasure of delivering defence projects, the maturity of the concept may actually be quite low. It could be emerging. And therefore, the project itself, without having firm guidance, needs to develop the concept as it goes. The scope necessarily is going to also emerge and develop through time. Another challenge of organisations that can deliver the capability often don't yet exist. An example is systems programs officers, so the engineering support type function, usually don't come into existence until the platform arrives. So when you're trying to do that early developmental work about setting the requirements, certainly in terms of engineering support, the organisation of your stakeholder might not actually be there. Cost estimates. I don't think I need to go into that too far. I think where if you've delivered one project, you know that cost estimates is not a small challenge. Just try doing cost estimates over a extended period. Long time frames enhances risk. I think they're both related. Assumptions and risk management. A continuing challenge. Risk management, both internal to the project, but also strategic risk, and how that can have an impact on projects themselves. Staff turnover, not only within the project team, but just the normal posting cycle. 2 to 3 years for most uniform personnel means that you've got a regular turnover of staff in key positions that needs to be managed. And my favourite, controlling the good ideas fairy. Along kind of goes hand in hand with posting cycles. The number of times that I've had a good ideas fairy visit with a change in posting of a principal. And that can occur 2 or 3 times through an extended project. Funnily enough, the benefit there, or sometimes the less of a challenge, is the good ideas fairy has the same ideas. So in addressing some of those challenges, I'd like to briefly speak to 7 suggestions, recommendations, or at least headings for them. So appropriate planning horizon. This is to deliver, or at least to drive success. There's a need or an opportunity to guide and support your stakeholders to foresee what the future might look like. If greater than 5 years hence, so it's a major capital piece of equipment is usually going to be in this realm, then consider foresighting as your tool, or at least a practitioner of foresighting to assist you in deriving or building what that future may look like. To work with your stakeholders to give them the security that they might need to be able to think that far ahead. What that will do for you is reduce the risk of strategic changes, but it also make some of the those smaller decisions more robust and resilient. I highly recommend building and recording and disseminating widely and frequently the narrative of the future state, what will be. It's a bit, certainly in business management, you talk about visions and mission statements, bringing people together about a shared vision. That's what the narrative of a future state will do. That narrative should be from multiple perspectives, aka the fix. It will serve to maintain stakeholder focus. It will be essential, or at least very useful for inducting new staff stakeholders, and will form a very robust defence against the good ideas fairy. If the good ideas fairy has visited, the idea has been discounted, you now have a record and a way to cover that the next time that the good idea fairy visits. Enable robust and resilient decision making. Now, this goes hand in hand. It's a bit of an outcome of a strong narrative of future state, but it provides the vision. The narrative of that vision needs to be compelling. But also, too, it needs to include indicators and warnings to monitor progress. It provides the guide rails, or the guardrails, I should say, the left and right of arc, so that should technology progress beyond the speed with which we anticipated, or indeed more slowly, then we have a way to monitor and cover that and include it in our future planning. Cost budget management, a normal requirement, but I'd suggest you consider 4 cost budget options. One being full, and that's to provide decision makers with an understanding of what it would cost to do everything. Optimal, basically the option that what is required to deliver as stated. The difference between the two is that between full and optimal, workarounds, operational responses are going to be required to meet that delta. Minimum viable capability, being that's not just what we can afford, but indeed the MVC and in budget may be the same, but certainly the minimal requirement to meet the stated goal. And then in budget, it wouldn't be the first time, I dare say, that any of our projects have not had the budget they required to deliver any of those other 3 options. One thing I will say, and within what I'm seeing in defence is a change in the definition, or an alternative definition for minimum viable capability, in terms of where it was first coined in ICT projects, but it was generally seen as being a waypoint. Provided a minimum a rollout of a piece of software to clients to give them an opportunity to at least start using and deriving some benefit, but with the intent of delivering something more solid, fulsome later on. What I'm seeing in defence, and certainly in the current fiscal environment, is that MVC is being taken as the destination point. So just be aware of that, and I would encourage you to open the conversation with sponsors around what their expectations are in minimal viable capability, and certainly within that cost budget management include all FIC. And all FIC will be involved in developing that capability. Scope prioritization. Unfortunately, you're likely to be faced with more scope than you have budget to cover. So my recommendation there is to ensure that your scope prioritization is principles based and have agreement on what those principles should be. I had the pleasure of doing 3 scope prioritization exercises, and the first and second barely changed. The third changed a little because of strategic circumstances, but the changes were relatively minor and weren't subject to egos or the charisma of the significant players. The other thing is, with scope prioritization, I recommend that you consider your response strategy. Certainly in my experience, it's been an all or nothing. You either can or can't afford a building, for instance. However, a more sophisticated, and use the term loosely, might be a proportional 80%. 80% of the occupancy required for a building might be a more appropriate response rather than an all or nothing. So, but that needs to be thought of very much earlier in the program than certainly what I had the ability to do with NCIS. Give assumption management the same attention as risk. It's a bit of a bugbear of mine with assumptions, certainly in infrastructure. But assumptions had been in some quarters used as or deemed to be fact. Even though we knew that those assumptions were subject to change, some of the people that I worked with viewed it as an assumption made to allow delivery. No, it's an assumption made to allow planning. I recommend 3 states: assumption, fact, and deemed to be fact. Deemed to be fact, then it's too late to change. And finally, capability is delivered through the integration of all fundamental inputs. There's 2 elements to a successful project: the fit for purpose product or major system, and then the coordinated integration of all FIC. We've traditionally done very well at the first. Second one, come see, come sa. We need to get better at integrating FIC. We also need, and this was within the defence organisation, to understand that the maturity of the systems that are in place are actually at a higher level than what we give them credit for, and should, as a result, be used as determining inputs to systems design.